Good morning, guys. So today we're going to finish chapter 9. Right before the last test, we did section 9-2, which was on inference for two proportions. So we looked at comparing two proportions, and whenever you compare them, you find their difference. Literally, you subtract the two proportions to find the difference between them. And so we did confidence intervals and hypothesis tests based on that difference. In general, the methods that we use in this class, we only assumed as our null hypothesis that they're the same. The most basic state is that you don't actually have two different groups. They have the same proportions. And then you test that. You see if either the true proportion is a smaller difference, meaning the first proportion is smaller than the second. I should say a negative difference, meaning the smaller proportion is, or first proportion is smaller than the second, or a positive difference, meaning the first proportion is larger than the second proportion. We're going to do the same kind of thing with means, right? So we're going to talk about a difference between means. Now, I noticed on the test that some of you were getting that notation confused a little bit. Sometimes when you meant a mean, you were using p, or when you meant a proportion, you were using mu, and that is opposite, right? We need to be really careful. P for proportion and mu, the Greek letter m, for mean. Okay, so be really careful. Here, just like we had P1 minus P2, now we have mu1 minus mu2 in section 9-3. That's the difference in means for two independent samples. So for two samples that don't have a connection to each other in any way. So one of the examples that we will do, or that is that we could look back at, I guess, is if we looked at two different samples of cookies, one from the Chips Ahoy brand and one from, like the Target Market Pantry brand. And we compare the number of chips in those two cookies. We take the mean from the sample of Chips Ahoy and the mean from the sample of Market Pantry. And when I say cookies, I mean like I'd have a sample of probably 30 cookies here and another sample of 30 cookies. They'd just be from separate brands. And then I'd compare their sample means. I would subtract them, see what the difference was. And I'd run my inference, my confidence interval, or my hypothesis test based on that. The example that we're going to work on first here is about caffeine versus no caffeine. So it's it explains the experiment in a little bit more depth. I'll go into that in a second. But the main idea is that the first group of students, their pulse rate change has nothing to do with the non-caffeine students. There's no relationship between the first number that's listed for the caffeine group and the first number that's listed for the no caffeine group. They're completely independent of each other. And so this obviously falls into our difference in two means for independent random samples. But then we are going to look at data that is matched or paired in some way. So you'll see those two words interchanged, matched and paired. So when we look at parts 3 and 4, they both deal with matched or paired data. The first example actually gives us data as opposed to just the descriptive statistics. So I'm going to talk about part 3. It's talking about these depression scores. So essentially they have the same person have an instance where they were able to get caffeine pills and they tested their depression score, and then where they were deprived of caffeine, where they were just given a placebo pill and they tested their depression score. So when we look at this data, we say subject 1 through 11 across the top. So the row that says the column that says subject 1, that's their data, their depression score when they had caffeine and their depression score when they had placebo. Those two values are definitely linked. They're paired. It's the same person. So that's different than when we had the independent random samples. And that's what we really have to be careful of here, okay? A lot of times this matched or paired data is before and after, or in this case, the two different treatments on the same person. Another way they could do that is to maybe pair like a husband and wife, if you're asking them different questions about their marriage, or if you wanted to even compare or look at, socioeconomic status and how that affects marriage, a paired couple would be important. So we need to be really careful moving forward that you are able to distinguish between when we have two independent random samples and we should be using the two sample confidence interval or hypothesis test for a mean difference, or whether we should be looking at, I should say, difference in means. Two samples has a difference in means, or whether we should be looking at a one sample interval or test for a mean difference. Because when we look at paired data, we will actually average their differences as opposed to finding their averages and then subtracting them. Those are two different things. Okay, so I feel like I've talked a lot and you're probably a little bit confused right now, and that's totally okay, but I just kind of want to set you up where we are going to do two different things here. And as we work through it, I think you'll understand a little bit better what I'm talking about. The other thing that's different about these notes today is that we are going to use a statistical program on the computer. It's called statdisc.org. It is going to ask you to sign in, use your whatever email account. It doesn't matter. I don't exactly know why you have to sign in because it's not paid or anything like that. But you do have to sign in. So make a choice on how you want to do that. This is the statistical program that's brought up in our book a lot. I don't know if it's made by our authors, but it's definitely partnered with the authors of this textbook. So I'm going to use that to actually do our do step for these, just because the calculations have gotten so complicated. I don't think it's contributing to our learning as much anymore. So we're going to use that feature to do our do step, but everything is still the same. Everything else is the same in our 4-step process. We're still going to state, we're still going to plan, and we're still going to conclude. And really, those steps are way more important than the do step. The reason we were focusing so much on the do step before is because it helps you understand what it is that you're concluding and what it is that you need to try to have as your parameter in your statistic. But now, hopefully, that we have a better understanding of that do step, we can kind of take a step back and let technology do that for us. Okay, so I'm going to be switching back and forth between, writing on my paper, writing that state plan, and then to the computer to do the do step, and then back to conclude. And that's going to work for all 4 parts. So I feel like there are going to be several very short videos in this one. Please don't get overwhelmed when there are a ton of videos. I'm hoping they're really short. Okay, guys, I'll see you in the next video.